a I'm trying to make this floor heater into a light panel. Just a DIY, just stuff kicking around. I've got some LEDs right here. I would really like to have LED strips. And then basically wire it up. I'll probably have to make a thin reflector, and then basically just wire it up. I'll probably use I've got a ton of old like laptop adapters and power sources, so I could try to once I make my workbench, my custom workbench, and just have my things sorted out, my tools, my electrical tools together, and my soldering irons. It's basically, without LEDs, I want to try to make LEDs, but that's not on hand right now. Instead, I've got Christmas lights. I had a little bit more, but I guess my parents threw them out. But basically, I've got enough. Oh, these might be no. But I like the LEDs a lot more. But these Christmas lights, you can cut them. I've got a few here that I've cut, and one side's positive and one side's negative. Oh man, I just lost a few. So I'll basically need to probably use like hot glue or glue, and I'll make a board the size of some of these fish tanks. Probably just make a cover, basically. Just a whole cover that'll be made out of wood. I'll drill some holes that I could fit these into. I thought these would be a little bit more industrial, where they wouldn't like sink in, or they wouldn't move much. But I guess I could just glue them, and I would have to solder. I would have to strip every single light bulb, put them into the hole, glue it, and then solder the wires. And if a light goes out, I could try to change it. This way, I could have something else useful for any Christmas lights, and to basically I cut them off to. Some people might not have to cut them off, but it's gonna be space, like conserving space, if you kind of do a little extra time take a little extra time to rework the whole grid. So basically, I need to get the board, a test board, and I need to, like from the bottom of a dresser drawer, or just something thin enough but sturdy enough. I might even use something more industrial, like metal, a sheet metal, if I could get one. I don't actually have any sheet metal, unless it's on the covers of appliances or VHSs. I could probably try figure something with my time. But so these are all my light bulbs, Christmas lights, that I'm gonna have to either cut, or I might try to make one of each just to compare. And too bad these aren't all LEDs. I wish I had this much in just scrap LEDs and I could make my own light. But the way how you wire them is like a positive and a negative from the current, and they can't touch or else it'll just spark and just kind of like, it's kind of like, it's different. It's a positive and negative because there's like a something with the type of metal or just type of particulates, or just what's that word, properties with electronics, and also a power source from the inverter and things where electrons kind of scoot along a wire at fast speed to, it's just moving just moving things that way. It releases energy or something. There's a lot better explanations, but basically it's a positive and like a negative connection, and each of these LEDs are one side has two legs, and one side's touching the positive and one's touching the negative. And then in this flashlight that I took apart, basically on the power where the batteries are, the battery adapter or pack part, there's a metal strip probably made out of nickel or tin or something, just aluminum, and basically it touches one of these rings, that's the negative, that brings it back to the battery or the power source, and there's actually brings it to the switch, then the power source, and you hit the switch and then it connects the circuit, so the light's always on, and then when you hit the switch again, it'll turn it off. It disconnects the circuit. So basically, this is just an example of a way to how the positive and negative can be connected parallel to each other to provide, electricity to light up light filaments that also gives off some type of it gives off, like, it's technically a spark, but it's enclosed in a vacuum, so it's a glow. So it's basically what I kind of drew right here with the negative and positives. And these lines are basically some wires that are going to go to this plug, and then there's a negative and positive plug, and basically there's these dots that are supposed to be light bulbs. And this is kind of half of what's happening. I've got to connect the negatives together with these other sides by all these positives are connected to each other for parallel. In a series, the positive will be connected to the negative, positive, negative, positive, negative, to build up voltage. But if these are all just kind of like on this, but if one of the things in a series circuit goes out, then you got to find which one went out, and then the circuit will. It's like a switch, basically. But in a parallel, if one goes out, the rest will still be working, and you could. So basically, I connected all these positives. You can pause this video to see, how to make a panel of lights, and then all these positives are connected, and then I've got to make like a jumper. An insulated jumper so the negative doesn't touch the positive, and these will be like stapled down, each of these wires. They'll be either stapled, they'll probably be stapled, or just I gotta find or tie strap, or maybe glued down real good, or maybe not glued, but just, they'll just be really, they'll be on tension, and then I'll solder the positive, to the positives. And then another tip about negative wires is the negative wire is always a little bit bigger, just to protect the instrument that's being charged up, so that it gets more ways out rather than building up and frying, building up energy from positive. If the positive was more mass, then it'll just build up more heat, or just voltage or amps, watts, and if the negative is too small, it'll just be like a bottleneck of just more energy. So the negatives kind of would be like a coat hanger. I can use a coat hanger and then a speaker wire, but this is better than it's not better, but it's a better DIY than most of these wires already insulated or already wired in a Christmas light rope. But I'm trying to work with what I have, basically. So basically, so I've got to also just have one area for the plug, and then basically the rest is going to just, and then I got to make sure the voltages, and just I'm basically making these videos so the information is out there, but it's going to take me a long time to do any of this stuff, if I even do it. It's just just my ideas to the story, and I'm just basically trying to share where I'm accessible to in learning about LEDs and making a light source. So and then after all these positives are kind of connected, you can solder it, and all this would be on like a panel of wood, or the cover of a VCR player or something, or just any kind of material. But then with the metal, the wire's got to be insulated or something, and you might have to have a cardboard type of insulator. But that's just when you're really going to try to build it. But drawing up some type of plan can just relieve you from having to research that stuff again, and making it possible. So it's having lights for aquariums are pretty necessary for but I'm gonna figure out about the negative, how they'll connect. It will just, if I drew in the negative, you wouldn't really know, from the negative and positive. But there's 8 or 4, 1, 2, 3, 4 negative areas, and they'll all be connected like the positives, but going into the negative. So thanks for watching. Wish me luck with this project, and maybe others. I like to do stuff all at once. So thanks for watching. Have a good one. Bye.